Welcome you all to the Stepwise Math channel. Today we'll begin with 7th chapter integrals from class 12. So in this video we'll cover what are functions, derivatives, antiderivatives, integrals, what is differentiation, integration, some signs and symbols, then why constancy is added after integration. So let us revise the definition of function, the informal definition of function. So here you just think that this is a computer and I label this computer as a function. Now if you send input to this function, it will process, it will operate, and it will give back an output, right? So I will take an example for this. If f of x is equal to sin x function, then if you send an input to this function, let us say x is equal to 0, it will operate. F of 0 is equal to sin 0. So what is the output you are going to get? Sin 0 is 0. So the output f of 0 is equal to 0. Now if you send input x is equal to pi by 2. Now it will process f of pi by 2 is equal to sin pi by 2. Sin pi by 2 is sin 90 degree and sin 90 degree is 1. So f of the input pi by 2 is equal to the output 1. So this is how function works. Did you observe anything? For every input you are getting a unique output, right? If you send 0, you can only get 0. You cannot get 0, 1, 2, 3 simultaneously. And if you are sending pi by 2 to the function, you are getting only 1 as the output. You are not getting 1, 5, 1.1 as the outputs simultaneously. So for every input, you will get a unique output. So this is what the function is. So for every input, you will get a unique output. Now we'll take one more example. Suppose let us say circumference, a function of radius. We know the circumference of a circle, which is 2 pi r. Now if I send the input radius equal to 1, so c of 1 is equal to 2 pi into 1, and the output will be c of 1, which is equal to 2 pi. So if for this radius 1 unit, the circumference will be 2 pi units. Right? You cannot have 2 pi, 4 pi, 5 pi at the same time. So for this input, a unique output exists of it. Now what are the other functions that we have seen in physics? So we have come across the function like pressure as a function of temperature. So input is the temperature and pressure at that temperature will be the output. Then volume as a function of time, right? Displacement as a function of time. Then we have also studied velocity as a function of time, right? Distance as a function of time, acceleration as a function of time. So every time you send a time as a function, you're going to get one output depending on the function, right? So these are all the ways that we represent the functions. Now let us know the functions that we have studied in class 11 and 12, so that it will be it will be a good start for the integration. So what are the functions that we have studied? X cube plus 3x square plus 2x plus 4, polynomial function. So we have studied rational function 1 by x minus 2, where x is not equal to 2, a function of this form, rational function. We have studied modulus function, trigonometric function, sin x, cos x, tan x, right? Inverse trigonometric function, sin inverse x, cos inverse x, tan inverse x. We have studied exponential function, a to the power x, e to the power x, e to the power x square, right? And we have also studied logarithmic function, log x plus b, right? So these are all the other, similarly there are many other functions like that. So now let's understand what is differentiation and derivative. For that we will take one example of a function f of x is equal to sin x, trigonometric function. Now we know this is a function. For every input there is a unique output. If we differentiate this function, differentiating both sides with respect to the variable here, the input x. If you take time, or if you write sin t, here we will write t. Differentiating with respect to x. So what do we get if we differentiate? D by dx of the function sin x, and this will be equal to, so you have learned now what is derivative of sin x, it is cos x, right? Cos x. So derivative of sin x is cos x. Did you observe 3 steps here? The first is the starting the function, then a process, differentiating, then you got the result, right? So it's the beginning, it's a process, and you got the result. So here this action or this activity or this process which from sin x to cos x, this is what we call differentiation. It is a process, it's a technique. Okay, I think it's nice if you say the word technique. So it's a technique of finding the derivative. So derivative is also a function, or we can say it's the result of differentiation. So here cos x is also a function. Cos x is the result of the derivative of sin x, right? So here function, we did the process, we got the result. So differentiation is a process, derivative is a function, it is also the result. Derivative of sin x is cos x. We have to remember this, which is very important. So derivative of sin x is cos x. Okay, yes. Now we will understand this through graph, because it's good. It's not just we are not just learning the formula, we are also understanding it, right? So here I have taken the graph f of x is equal to sin x. So here the inputs are on the x-axis, and the output what we get we will plot on the y-axis, and we will get a smooth fine curve, and it continues on both the sides, but I've just taken one cycle. So here 0, pi by 2, pi, 3 pi by 2 and 2 pi. So when the input is 0, the output sin 0 is 0. When the input is 90 degree, sin pi by 2 will be 1. Sin pi by 2 will be 1. If the input is pi, right, sin pi is 0. So that's why we have drawn here. Then sin 3 pi by 2, sin 270 degree, which is minus 1, and sin 2 pi is 0. So in between for all the angles we'll get many infinite points here, and we have connected them, and we have got this smooth curve. Okay, function is fine. Now we have seen 3 steps, right? Function, differentiation and derivative here. So function is there. Now where is that differentiation and derivative, right? So for that, what we will do is we will take one point input. So I will select pi by 2 as the input. Okay, you can select any point, but I'll select pi by 2 now. Now at this pi by 2, I will join with the graph of that curve, and I will draw the tangent at this point. Okay, so I'm drawing a tangent at this point. Now what is the slope of this tangent? What is the slope of this tangent at this point, input pi by 2? So here we know the slope, right? When the line is straight, the slope is always 0. So when you're walking on the straight path, do you experience any slope? No, right? So the slope is 0. But this derivative will help you to confirm that the slope is 0. See here, this function is f of x is equal to sin x. Now derivative of sin x is cos x. Now, so what is the input here? Pi by 2. At which point we have drawn the tangent? Pi by 2. Cos pi by 2. And how much is cos 90 degree or cos pi by 2? 0, right? So that's why we will write here. So the derivative of the function of this function at pi by 2 is 0. So how did you got this? Because of this derivative, you got the slope of this tangent. Right? So now let us take one more point, 0. Now if I draw the tangent, okay, we'll draw the tangent. So if I draw the tangent at the point input x equal to 0, now what is the slope of this line? What is the slope of this line? How do you find the slope of this line? There is a slope, right? There is an upward slope here. So here the slope is 0 because you are just walking on a straight line. There is no slope. So here there is a slope. It is like some mountain. You are climbing some mountain. There is a slope. So how do you find the slope value of this graph? You will go to the derivative. You will ask the derivative to tell what is the slope at the input 0. So how much is cos 0? 1. So that is the main task of derivative. It will tell you what is the slope of this graph at any point. So here the slope is 1 and here the slope is 0. So I hope you understood what is differentiation and derivative. So why we explained here, because so that we can connect to the integration. Okay, so let's move to the next part. Now we will understand what is integration and antiderivative, which is also known as integral. So antiderivative, integral, both are same. So for that we'll take one simple example and we will apply arithmetic operations, and then easily we can understand what is integration. So let us take a quantity 1. Okay, so there's a quantity 1. Now, so I will divide this quantity 1 by 4. So if you divide 1 by 4, what you will get? 1 by 4, or you will get 0.25, right? So 1 is divided into 4 equal parts. Now I want that one whole part again. You have already broken into pieces. But now I want that complete part, complete one part. So what I have to do? So I have to perform another arithmetic operation that undo this, right? Undo in the sense I have to go back, like how we do in editing. We have to, if we don't want something, we'll just undo it, right? So in the same way I want to go back to 1. So what I have to do? I have to take all that 4 pieces and you have to multiply, or 1 by 4 by 4. So if you multiply 1 by 4 into 4, so what you will get? 1 by 4 into 4. So 4 by 4 will get cancelled. You will get 1, right? So you got 1 back, right? So 1, you took 1, you divided by 4, got 1 by 4. So again you multiplied by 4, you got 1. So you got that thing back. So in between you did the 2 operations. What's happening between division and multiplication? They undo each other. They cancel out each other. So you did the division, multiplication cancelled it out, and you got back the original number. In the same way, first if you multiply by 4 and then you divide by 4, again you will get the original value. Okay, so now let's take the function f of x is equal to sin x. Okay, f of x is equal to sin x. Now we will differentiate this. So we will differentiate this one. So we'll apply differentiation, we'll do the differentiation. So I'll write differentiation. So if we do the differentiation, so what will happen? Derivative of sin x. So what is the derivative of sin x? We will get cos x, right? So you took the function, you did the differentiation, you got cos x. Now I want that sin x back. So we want that sin x back. And now we have this cos x with us. We want this sin x back. So how do we get it? There comes the integration. There comes this integration that will tell you, yes, I am there to give back sin x to you. So how does it give back? So integration of cosine x. Now here we have taken x, so I'll write here dx with respect to x. And you are back with the original primitive function sin x. So here what's happening is differentiation and integration cancelling each other, or even if you do first integration and then differentiation, you will get that original function back. Some formulas for that, there are some properties which we'll discuss while solving the problem, but this is the basic idea that you have to know. So I think now you understood what is integration. Even it's a technique or it's a process or it's a way, we can say, that helps you to get back the original function. So now we will understand what is antiderivative and or integral is. So when you have the function f of x is equal to sin x, so you will differentiate the function with respect to x. Derivative of sin x is cos x. So what did I just say? Derivative of sin x is cos x, right? Now derivative of sin x is cos x. Antiderivative of cos x is sin x. So if the derivative of sin x is cos x, the antiderivative of cos x is sin x. Or we can say the integral of cos x is sin x. So I hope you understood the concept. So antiderivative or integral. So antiderivative of cos x is sin x. Can you observe even this is also a function? So we can say antiderivative is also a function, right? Antiderivative is also a function. We can also call it as a primitive function or the original function that you get after doing the integration. So I hope you understood what is integration, antiderivative or integral. So whenever we integrate the function with respect to x, that is what we write in dx, what we get is a original function, and we will always add plus c. Okay, we will always add plus constant at the end. So this part will be given to us. What do we call this as the derivative? And we will integrate that derivative part. We will get the original function or the antiderivative or the integral, and after that we will always add constant c here. Now it's the time to know why constant c will be added. So now we will understand why constant c is added. So here I've taken a graph. This orange color is f of x is equal to x square, or we can also write x square plus 0, right? No harm. Next, another graph, f of x is equal to x square plus 2. So these two are parabolas. So here x square plus 0, x square plus 2. So all the values from the orange graph, all the points on the orange graph will shift to 2 units upwards. 2 unit upwards, vertical shift. and you have f of x is equal to x square plus 2. Now we will differentiate and then we will understand why constant c must be added. Okay, so here if you differentiate the function x square plus 0. Now if you differentiate x square plus 0, so what exactly you get if you differentiate x square? We get 2x, right? Now we'll differentiate this function x square plus 2. So if you differentiate x square plus 2, what you're going to get? This will be 2x and derivative of 2 is constant, which is 0. See, both of them got the same value. Derivative of x square is 2x. Derivative of x square plus 2 is also 2x. So just for your information, derivative of x square plus 100. So differentiate this x square plus 100. What you will get? Derivative of x square is 2x plus derivative of 100 is 0. So you are just left with 2x, right? So what can you observe in this? There are 3 different functions, but the derivatives are all same, right? Derivative of x square is 2x. Derivative of this function is also 2x. Derivative of this function is also 2x. Different functions, same derivative. Okay, that's okay, no problem. In the differentiation chapter, that's what we learned, right? But in integration, the case is different. Derivative will be given to us. We have to find this original function. Derivative will be given, we have to find the original function. Derivative will be given to us, we have to find the original function. Now, if they give the derivative 2x with respect to x, what you will write here? Whether you will write the original function as x square plus 0, whether you will write the original function as x square plus 2, or you will write x square plus 100, what you have to write? This one, this, or this. If you write this, we don't know, we are not sure it can be in this function also. We don't know whether the function can be this also. We don't know, right? Yes, this is where the constant c plays a major role. We will write x square, okay, because we know the original function of 2x is x square, the original. So now which one to write? So this plus c is there to just balance that out of the same family, it can be any member. This is all, they all belong to the same family, right? And it can be any member from the family. It can be x square plus 0, it can be x square plus 2, it can be x square plus 100.